Hey everybody, do watch this recording. This recording is about electrical energy and electrical appliances. Okay, each and every month we have to pay electricity bill. We are using various electrical appliances at our home. They consume electrical energy, and based on the electrical consumption, at the end of the month we have to pay electricity bill, right? So let me begin with this. We have to basically we are going to discuss about electrical energy and power consumption. kWh, this is electrical meter. Okay, we are already aware of this. kWh, k kilowatt hour. Okay, kilowatt hour, is it a unit of power? Unit of power is watt, right? kWh is a unit of energy. Which energy now? Electrical energy. Okay, SI unit of energy is joule, but in case of electrical energy we use kilowatt hour. So let's learn about it in detail. Okay, so let's begin with the watt. Actually, what is watt? What? Sorry, audio. Let's begin with the power. Okay, as you can see here, this bulb is of 9 watt. The W stand for watt. So watt is the unit of power. Okay, this is what we have learned in chapter number 3, work, energy and power, and this is the formula for power which I have already written over there. Joule per second or watt, this is the unit of power. Now this electrical bulb is converting electrical energy into light energy, so it's also doing some type of work actually. Okay, now its power is mentioned 9 watt. So what is the meaning of that actually in terms of joule per second? What is the meaning of that? Let me write it here. Its power is mentioned 9 watt, means 9 joule per second. It means it's converting 9 joule of electrical energy into light energy per second. That is the meaning of this rating. So nowadays we are using LED lights. Okay, they consume less power and we can save our electricity, so we have to pay less bill as well. So these are the few questions. Explain the meaning of statement power of an appliances 100 watt. So suppose that there is an appliances whose power rating is 10 watt. So sorry, 100 watt. So what is the meaning of this actually? It means it's converting 100 joule of electrical energy into, if it is a light bulb, so it will convert 100 joule of electrical energy into light energy per unit second. So 100 joule of electrical energy is consumed per second. Okay, in another way. So that is the meaning of this power rating. 100 joule of electrical energy is consumed by that appliances per unit second. This is the meaning of this rating. So in case of this light bulb, it will consume 9 joule of electrical energy per unit second. So that electrical energy will be converted into light energy. So each and every device has its power rating. Now there is a relationship between power and energy. So using this formula we can understand it. P power, let me write the unit here, watt, and W is joule. Okay, joule. Let me write J only, it's okay, it's understood. And the unit of time is second, right? So if I bring second on this side, I mean if I write this formula in this term, W is equal to PT. Okay, so using this formula we can derive the relationship between watt and joule, which is unit of energy, right? So we are talking about appliances. Okay, their unit is mentioned in case of watt, and when we run them for 1 hour, okay, suppose that I am taking time as 1 hour, WH. So here the energy unit will be WH, watt hour. generally we use kilowatt hour because watt hour is a smaller unit. So, we use bigger unit of electrical energy which is kilowatt hour. So, this is the relationship between power and energy. So, based on that information, I think you will be able to answer this question. Name the physical quantity which is measured in kilowatt. So, this is power, certainly this is power. What is kilowatt hour now? Kilowatt hour means this is a formula for energy or work. Kilowatt hour is a unit of energy, right? Achha, what about watt hour? That is also a unit of energy. So, if my power is in watt and time is in hour, so watt hour will be the unit of energy. This is for power, this is for power times power into time, that is unit of energy, power into time, that is the unit of energy. So, as we can see here, power unit is watt according to this formula. Let me write it here, work done per unit time. So, if I arrange it, it will be like W is equal to W is equal to P into T, right? P into T. So, this is my final formula using this. Let me erase this part now. Oops, sorry. So, power they have mentioned here. For example, 25 watt bulb. If I use it for 3 hours, okay. If I use it for 3 hours, so my energy consumed will be E for energy, power 25. How many hours? 3 hours. So, that will be 75 watt hour, isn't it? And if my bulb is of 100 watt and if I use it for 3 hours, so my consumption will be, energy consumption will be 300 watt hour, not my actually energy consumed by the bulb. So, accordingly I will have to pay the electricity bill. So, like I said, SI unit of energy is joule, right? Joule. But here in case of electrical energy we use watt hour, which is basically equal to 1 joule. No, sorry, which is not equal to 1 joule. This is what we need to find out. How many kilowatt hour, which is the unit of electrical energy, equal to how many joules. So, what is the relationship between kilowatt hour and joule? Let's check out. Let's check it out. So, yeah, this is the conversion. This is the relationship between kilowatt hour and joule. Okay, so kilo 1000. So, they have put 1000 value here. Watt is a SI unit. In 1 hour, there are 3600 seconds, isn't it? So, if you multiply 1000 into 3600, I mean 3600, you will get this huge number, 36 followed by 5 zeros. Okay, that can be written in this form, 3.6 into 10 raised to 6 joule. It means 3.6 mega joule. Mega means 10 raised to 6. So, this is the relationship between kilowatt hour and joule, kWh and joule. So, basically all you need to do is put the value of R. In 1 hour there are 3600 seconds and multiplied with the kilo. Kilo means 1000. Rest is SI unit. Okay, so this is the conversion factor. So, let us go through these questions once again. What is consumed while different electrical appliances for which electricity bills are paid? So, what is consumed? Electricity is consumed, right? Electrical energy is consumed. Kilowatt is the unit of power and kilowatt hour is the unit of electrical energy. Even watt hour is a smaller unit and kilowatt hour is a bigger unit. Okay, now let's check these questions. Name SI unit of electrical energy. SI unit is joule. Okay, SI unit is joule. SI unit of all the energy is joule. How is it related to watt hour? So now watt hour. Okay, watt, 1 watt. Okay, not kilowatt, this is 1 watt. Okay, in 1 hour we know that there are 3600 second. So 3600 watt second. Watt second is joule. So 1 watt hour is equal to 3600 joule. When we add kilo, it will become kilowatt hour. In that case, the final number will change here. So that is not asked, so I am not doing that here. State the SI unit of electrical power. Okay, SI unit of electrical power is watt hour, but it's a smaller unit. So basically we use kilowatt hour. Okay, kilowatt hour. Now 100 watt, it means it's converting 100 joule, sorry, it's consuming, yeah, converting or consuming 100 joule energy, electrical energy per second. So if it is a bulb, it will convert 100 joule of electrical energy into light energy per second.